If you've ever lost a print to a mid-air jam, especially running PLA or PETG, you know that feeling of pure frustration. It's often caused by something sneaky: heat creep. That moment when heat travels too far up your extruder, and it softens the filament too early, and causes a clog that ruins everything. But what if there was a simple plug-and-play fix? That's exactly what I'm testing today: the Martillo Tech Extruder Cooler. It looks like a mad scientist's humidifier, but it might just solve one of the most annoying issues in 3D printing. Let's not waste time, let's make it, let's print it, let's roll the video. Hey guys, welcome back to my channel. My name is Alessio and this is Pixel Forge Lab. I've been away for a while, but I am back. First thing first, let's take a look at the box and first impressions. First thing we see is a user manual, and it's really well done. Couple of pages, but it's really well done. And right away we have the unit itself, and I have to say it looks really professional and premium. At first glance, this thing is a bit of a unit. The first thing I noticed right away that this thing is 3D printed. You can see it right away. This was probably the side of the build plate. This looks really good. Air output port and a bundle of tubing and accessories. The heart of it is a cooling and dehumidifying system that sends cold, dry air directly into the extruder via a modified PTFE tube. Why? Because keeping the upper part of your extruder cold prevents a premature filament softening, and it's fully compatible with AMS setups, which is very impressive considering how touchy they can be. So how does it work? Here what's happening inside. The cooler chills the air and removes moisture using a built-in condenser. That dry, cold air gets pushed through a PTFE tube that connects directly to your extruder's heat sink. The air helps to regulate temperature and eliminates moisture buildup that could mess up filament feeding. There's also a Y splitter system that lets filament feed normally while cold air surrounds it. No back pressure to the AMS, and no interference with the filament path. Installation is easier than it looks. You cut the Bowden tube between the AMS and buffer, then you insert the supplied air bleed adapter, which prevents pressure issues. From there, you attach their high-flow PTFE tubing and route it to the Y splitter near the extruder. It's all push-fit, and you get detailed instructions with QR codes linking to videos. I had it up and running in under 30 minutes.
A big thank you to PCB Way for sponsoring today's video. With more than 10 years in the industry, PCB Way is your good-to-go partner for PCB manufacturing, prototyping, and assembly. They deliver consistent, high-quality results with fast lead times and offer much more than PCBs, including CNC machining, sheet metal fabrication, injection molding, and advanced 3D printing in materials ranging from resins to metals. Whether you need a single prototype or thousands of units, PCB Way makes it simple. Use the link in the box below to start your project and claim your $5 welcome credit.
And now for the good stuff. I ran 2 identical prints, a multi-material prints, with a lot of filament swaps.
And here we go, after 13 hours print and 373 filament changes, and this is the one with the Martillo Tech Extruder Cooler active, and we can see behind all the poops, and it was quite a bit. And for material we use Bambu PLA Basic, so it's the same thing for both of them. And first inspection, we can see it's pretty much perfect. There's maybe a little wisp here and there, but not that visible. Let's gonna check the other one. And this is the other one without the Martillo Tech Extruder Cooler, just normal. Same thing, 373 filament changes, Bambu PLA Basic, and 13 hours print. First inspection, I don't see much difference, maybe a tiny bit, but we need to remove it and check it properly. And here on my left, we have the one printed with the Extruder Cooler. The head came out really well, and the body as well as the wing. I don't see any imperfections. And on my right, we have the one printed without any Extruder Cooler. And this one is fine too. I don't see any imperfection. Maybe it's slightly worse. I can see a little bit on the body, but I'm not sure. This is the one without, and this is the one with the Extruder Cooler. We need to get a little closer. It's really hard to see even with the magnifying glass, but I don't see any imperfection on this one. And on the other one, still not that much. It's actually really hard to recreate a problem when you don't have it and you actually need it. Let's say that this one, printed with the Extruder Cooler, it's slightly better. After inspecting the body, I can say that these spikes came out really well, and now we're gonna check the other one without. I would say yes, it's like 5-10% a little bit better than the other one, so yeah, it is a win. So both models came out great. Obviously, the one on the left, it's slightly better, like 5-10% better, and this is the one printed without the cooler. Also want to thank STLFlix.com for providing these models, these amazing models. So if you want to check them out, there is a link in the description down below.
I've noticed that the extruder motor was cooler to the touch after 20 minutes. That means it's doing more than just moving air. It's actually affecting the thermals. One thing I loved, the moisture collection bottle. You can see bubbles foaming and water condensing during prints. That is to prove it's working. Let's break it down with the pros and cons. Pros: actually prevents heat creep, doesn't interfere with filament feeding, compatible with AMS, and the moisture trap is a nice touch, and it's relatively quiet. Cons: it's $150, it's not cheap, and it does take up some desk space. It will not fix printing issues unrelated to heat creep. So, is it worth it? Well, if you're using a close printer or printing in high temps, yes. For casual PLA printing in a cool room, maybe not. My final thoughts: bottom line, this is one of the smartest upgrades I've tested this year. It doesn't promise better print quality, it promises reliability, and it delivers. If you have had jams, mystery clogs, or inconsistent extrusion, especially on long multicolor prints, this might be the fix you didn't know you needed. This was kindly sent to me for free to review, and my opinions were completely mine, was not affected by the company. And would I buy it? Absolutely yes. So let me know in the comments what you think. Is this the kind of upgrade you would consider? Drop a comment, like, and of course subscribe if you're not subscribed yet for more real-world tests and printer upgrades. Thank you so much for watching, and as usual, I'll catch you on the next one.